In this lesson, I will discuss how to get started with R. We'll start with how to install R and RStudio. We'll discuss the interface a bit, and we'll start writing a bit of R code to see some of the capabilities of the program. So you may be new to R, and may be wondering, what is it all about? R is a programming language that is used for statistical computing and graphics. Now, RStudio is an integrated development environment, an IDE, basically a point-and-click collection of tools where you can run R commands, view figures, import data, and organize projects. The first thing you should do is download and install these programs. One thing to note is that you should install R first. Once R is fully installed, then install RStudio. Once everything is installed, open RStudio. You will see three panels. The console panel. This is where R commands are entered and output is presented. The environment. This is where variables, functions, datasets, and other objects are listed. And the general panel. This is a multi-use panel which we'll use for various things. We will often use a fourth panel called the source panel. This allows us to write a script of commands prior to running them. To view the source panel, click on the icon at the top of the console panel. Scripts written in the source panel can be saved or loaded as needed. Generally, we'll consider it to be good practice to write R code in the source panel and run it line by line. To run code on a line in a script, either click the Run icon or Control-Enter on PCs or Command-Enter on Macs. Let's get started writing some R code. Okay, so here we are in R, and we see the three panels. We see the console panel, the environment panel, and the general use panel down here. I want to point out just a few things with that. One thing is that if I type something in here, I type in a command in R, let's just do something like 5 times 3, and I run that. Notice how that shows up here in the History tab, and so I can easily keep up with the various commands that I've run over here. I will also point out that we saw in an earlier video that if you go to the Environment tab, you can import a data set here. This is an easy way of importing data that comes from a local file. Down here in the Multi-Use panel, if you click on the Help tab, then this is an easy way of getting help with R. For example, if we want to find some information about the mean command, I can type in mean, and it shows me all I need to know about this command, how to run it, what arguments go into it, and all of that. I'm going to open up the source panel up here. I'm going to click on this little icon, and that has opened up my source panel, and I'm going to open up a script that I've written for this. So in this script, we're going to work through a few different things. We're going to get to know R and see some of the different capabilities of it. So the first thing I want to point out is that if you want to put a comment in your script, you precede it with a hashtag. R will ignore anything that comes after a hashtag. It's just a comment. And I think it's a good idea to write comments in your scripts just to keep things organized, and you can keep up with which actions are being done in your script. Now, one way of thinking about R is as an enhanced calculator. It can do addition. So here I've got the command 2 plus 2. When I run that, I can see that it adds those. It gives me 4. It can do multiplication pretty easily. Exponents, -3 quantity raised to the second power. If I run that, then I get 9. Now, one thing I'll point out down here is that in the output, you see there's a bracket here with a 1 inside of it. That can be ignored. That's really just saying that this is line number 1 of the output, and if you have something that's really long, then you may have more than one line. We can do rational exponents in R, 100 raised to the 1/2, which is the same thing as the square root of 100. If we run that, we can get it. There's also a square root command that you can run. You can do e raised to a power, that's with the exp command. You can also do cosine pi over 3, trigonometric values, and we see that all that is pretty straightforward. R can do logic operators. It will return a true or a false based on whether the statement is true or false. For example, 4 is less than 10. That's a true statement. So when I run that, I see that it returns true. 7 is equal to 7. And notice the way that R uses the equivalent command here. It's equals equals. So 7 is equal to 7. Well, that's a true statement. How about 5 is less than 2? Well, we know that to be false. When we run that in R, we see that it will return a false. 8 is less than or equal to 8. And again, note how this is inputted. It's a less than followed by an equal sign. And because 8 is less than or equal to 8, we see that this will give us a true. 3 is not equal to 4. And note how this is inputted. Not equal to is an exclamation point followed by an equal sign. And because 3 is not equal to 4, we get true. Here we have a compound statement. The AND sign right here says that both of these things must be true in order for it to return a true value. And we have 2 is less than 4 and 13 is less than 10. Because 13 is not less than 10, we expect to get a false value here, and that's exactly what we get. The OR operator says that it will return a true if either one of these is true. And so we have 2 is less than 4 or 13 is less than 10. Because 2 is less than 4, when we run this, we see that we get a true. We can make variable assignments. We do that using the assignment operator. That is a less than sign followed by a hyphen. Suppose that we want to define a variable, var.1, and we will enter the value 12 into that variable. Then we would do that with this type of command right here. 12 is assigned to the value of var.1. And if we call up what's in var.1, we see that it returns 12. Let's assign 8 to var.2. And if we call up var.2, it returns 8. Well, now that R knows that var.1 is 12 and var.2 is 8, we can use those variables in other operations. For example, let's define a new variable, sum.of.vars, and this will be var.1 plus var.2. At this point, the assignment has been made. Now let's see what that value is. It's exactly what we expect it to be, 12 plus 8, which gives us 20. Suppose that we want to define a data array, that is just a list of numbers, like a data set. Suppose that we have the array comprised of values 1, 2, 3, 4, and 5. Now the way we put this into R is C, open parentheses, and then we put in each of these values followed by commas, and then we close out the parentheses. So let's define the variable data.set.1, and in that variable, we will assign the data array, which is comprised of the values 1, 2, 3, 4, and 5. So let's run that. And so let's call up data.set.1 and see what's in there. And it returns exactly what we expect, 1, 2, 3, 4, and 5. Now let's assign another data set comprising the values 5, 2, 0, 9, and 15. We'll call this data.set.2. Okay, so we have dataset1 and dataset2 defined. We can now perform element-wise operations on the datasets. For example, dataset1 plus dataset2 will add the first elements and the second elements, and so forth. We see that we get 6, 4, 3, 13, and 20. We can subtract dataset2 from dataset1, or we can multiply the elements in dataset1 by the elements in dataset2. Suppose that we wanted e raised to each of the values in dataset2. We can do that with the exp command. Now let me point out something here. Note that the output is in scientific notation. For example, the value 1.484132 E02 is really equivalent to 148.4132. The E02 indicates that we should move the decimal 2 places to the right. Let's take the square root of all the values in dataset 1. Okay, so all those examples involved element-wise operations. We can also perform operations on an array itself. For example, suppose that we want the sum of all the values in dataset 1. We do that with the sum command. We can find the mean of all the values in dataset 2. Let's find the length of dataset 2. Now what this will do is it will return how many values there are in that array. And we see that there are 5. Okay, let's talk about a process for importing data. Generally, the process will involve cleaning up the data in a spreadsheet program, saving it as a CSV file, a comma-separated values file, and importing it into R. Now my suggestion is that you save your CSV file into a Dropbox folder. You can visit www.dropbox.com to open a free account. We're going to copy the Dropbox link and import the file from there. The reason for doing this is that this allows your data to be imported from different instances of R. For example, if you want me to help you with your R code, I will be able to import your data without you sending me a separate file. Or it may be that you want to work on R from different computers. This process means that you don't always have to have local copies of your data files. In the last lesson, I saved a file about insect frequencies in Dropbox. The following process will import this data into R. The first thing I'm going to do is call a library which facilitates the importing of data. And that's with this command right here, library reader. Now I'm going to go on my computer and I'm going to find the Dropbox link of that CSV file. And I've got it right here. Now this is in my Dropbox. I'm going to right click and I'm going to copy Dropbox link. So let me paste this here. Now in this script, these are just comments. I'm just pasting it here so that I can look at this link. Now when you're doing it this way, you need to change this very last part of the link from a DL equals 0 to DL equals 1. What this does is it forces Dropbox to deliver the contents of the file instead of just a link. So I've got my updated link right here. So now I'm going to read in the file. This is done with the read.csv function. If the file contains headers, use the option header equals t. Otherwise, just omit the header option. So in this command, I'm going to assign to this variable, insect_freak, the contents that are coming from this file. I paste in the Dropbox link here. Make sure you include the quotations around it, and then run this command. At this point, I've got this assigned in R, and I should be able to take a look at it. I'm going to do this using the view command. And with this command, note that V is capitalized. We can see now that R has access to this frequency distribution that we just imported. Now I know that seems like a bit of a complicated process, but after you do it a few times, it becomes second nature. In the last lesson, we looked at data on Bigfoot sightings. Let's import this data into R. I'm going to assign the data into this variable Bigfoot. So let me go and find this on my computer. I've got my file here. It's a CSV file. I'm going to right-click on it and copy the Dropbox link. And then I will use the read CSV command here. I'm going to copy in this link and change the DL equals 0 to DL equals 1 at the end. That data now exists in R. I can take a look at that file. Now one thing that I'll note here is that there are 4 variables in this file. We have state, we have date, we have temp, we have moon phase. So I'm going to take this one step further. I'm going to attach that data set to our workspace. This makes those different variables available for R commands. So I do that with the attach command. And so those variables, state, date, temp, moon phase, are all now available to use in R. For example, suppose we wanted to find the mean of temp. We see that that is 67.277. And so now you've seen some of the capabilities of R. In particular, you can use R as a calculator. You can assign variables. You can insert data arrays. We can do different operations with those data arrays. And we've seen a process for importing data from a Dropbox folder. Now I want to finish up this session with just some RStudio tweaks. So one thing I suggest you do is go under Tools and Global Options, and under the General tab, I suggest that you uncheck the Restore R Data into Workspace at Startup. If this is checked, then RStudio will save all functions and variables and data sets that you have used in your session, and it'll make it available the next time you load RStudio. Generally, I find that to be more cumbersome. I like to start with a blank slate every time I go into R, and define variables as I need them. So once you uncheck that, click Apply, and then we'll move on to our next tweak. The next tweak is to look at the Code tab over here. I suggest that you use the soft wrap for R source files. Make sure that this one is checked. What that will do is wrap your scripts up here. If I uncheck that, you can see that it makes this a little harder to read. You have to scroll over to see what else is in that script. The third tweak that I want to point out is that under Tools, Global Options, Appearance, you can choose different themes for the editor. From this point on, in all future videos, I'm going to use the Cobalt theme because I think it's a little bit easier on the eyes. So I'm selecting Cobalt, Apply, OK, and this is how the videos will look from here on out. I'm going to wrap up this session, and the next thing we'll talk about is R Markdown. All right, so we're going to talk about R Markdown. And R Markdown is a way of printing out as an HTML or a PDF or as a Word file different things in R. You can print out your code. You can print out commentary that goes along with the code. You can print out plots. So let's just get into R and demonstrate some of it. At this point, I assume that you have already installed R in RStudio and maybe played around with it a little bit just to input some commands and see how it works. I'm going to go up here and I'm going to press File and then New File, and I'm going to select R Markdown. Now when you do this, it's going to ask you for a title. It'll also ask you for the author, and the author may be filled in already. And then it's going to ask you, well, what's your output format? Do you want this as an HTML file, or a PDF, or a Word file? And don't worry too much about this because you can always go in and change this. I'm going to call this R Markdown Demo. And press OK. Now be aware that if this is the first time you are trying to create an R Markdown document, it may ask you to install or update some packages. Now what you can see is that up here we've got some information. These are the parameters of the document, and then there's a whole bunch of other stuff that shows up. What's showing up here is really just demonstrating what R Markdown can do. I want to point out one thing here. Let's look at the knit icon. The way we'll create our HTML or our PDF or Word document is by clicking on knit. Let's go ahead and press knit at this point just to see what this document will do. Now first it's going to ask me to save this file, so I need to give it a name. I'm going to call this R Markdown Demo. And after that is saved, it has now created this HTML document. And you can see that we have R code and R plots and general text here as well as links. So we're going to see how we can create those. Let's close this out. Now I'm going to erase everything below these initial parameters right here. So let's just delete all of this. And essentially we're just starting with a blank document. If we click on knit at this point, you will see that we have a document that doesn't include anything other than those initial parameters. So let's just start by typing something. This is an example document. Let's try hitting knit again. And we see that text showing here. Let's talk about some formatting. A single hashtag gives us a level heading 1. A double hashtag gives us level heading 2. And a triple hashtag gives us level 3 heading. Let's knit the document to see what this looks like. So we can see the difference between heading 1, heading 2, and heading 3. If we want to italicize something, we use asterisks around it. If we want to bold something, we use double asterisks. Let's take a look at this. Now one thing that happens sometimes is that you see that these two phrases are on the same line. And that's not exactly what I wanted. But it's pretty easy to solve that, and you do that just by inserting a line between those two. Suppose I want to include a website. Well, I'll put some text in first. And now I'm going to use brackets. Now what goes inside the brackets is the name that you want to appear for that website. Here the name of my website is MGA Calculator Tutorial. At the end of that, you open parentheses, and here's where you will actually put in the link. Let's knit this to take a look. We can see that we've got here's a website to visit. It's got the name of the link right here, and if I click on that link, it opens it up for me. Okay, so at this point we have seen how to enter text, enter some formatting such as headings 1, 2, and 3, enter italicized elements and bolded elements, as well as how to enter a website. Let's demonstrate how to enter some R code. To enter R code, I'm going to press this icon up here, which is the Insert Code icon. Now it has lots of different options here, and if you know how to code in those different programs, then you're welcome to use them. Here we're just going to select R, and what it has done is open up what's called a code chunk. We've got the beginning and we've got the end here, and we would put our R commands in between. Okay, so let's try something out. I'm going to define a variable, and this will represent English grades. I will put in here a data array that consists of 4 grades, 95, 82, 85, and 88. So let's also put in math grades. Here I have the values 100, 80, 90, and 92, and I'm assigning those to the variable math.grades. So how about we just start off by printing out the grades, and then maybe we can do a scatter plot of English and math grades. Now I know that we haven't covered many plots yet, but let's just go ahead and put this in and see what it does. Now I'm going to knit this and see the output. Here we have our R code, and notice how R code is placed in a box and output is also placed in a box. So here we've defined our English and math grades. We called English grades and here was the output. We called the math grades and here was the output of that. We had a plot command, and then here is the output of the plot command. From this plot I can see that there is a positive correlation between English and math grades. Remember that positive correlation means that as one goes up, the other goes up as well. So maybe that would be a comment that we want to put in here. And it seems like a rather important one, so I'm going to bold it. And now let's take a final look at our document. We see all of our R code, the plot, and the comment that we just made about it. So you will need to get comfortable with R Markdown, because there will be occasions in this class on which you will need to submit your work in R. Okay, so that's it for this lesson. Best of luck as you work on the quiz and as you move on to the next one.